In the previous video, we looked at different levels of testing. So we start with unit testing where individual functions or units of the program are tested, and then these units are incrementally integrated. And then the fully integrated system is tested, and finally we give it to the customers. Right? So these are the different levels of testing. And in this video, we are going to focus on unit testing. So before we look at the different aspects of unit testing, here's a reflection spot. So why do we actually need to do unit testing? Right? If you see, it's a very painstaking process of individually testing each module, right? And then we have to integrate and test all of these modules once again. So why not just integrate and test once and for all, right? It can save time and effort of the developers also. So why do you think unit testing is important? So please pause the video here and write down your responses before proceeding. Okay, so why do unit testing, right? So one reason is that, as we saw earlier, modules are not developed by a single developer, right? They are developed by different people who are building other modules also, right? So while I am developing a module, right, the other modules might not be ready at all, right? And hence it is not possible to do system or integration testing at the start itself, right? And another important reason why we should do unit testing is that it makes debugging easier. So let's say a failure or error is detected, right? And when an integrated set of modules are tested, so how will we know which module has the error? Right? So on the other hand, if we tested each unit individually or each module individually, we can resolve the bugs and failures in each module. And hence unit testing makes debugging easier. So these are some reasons why we should do unit testing always. So now let's look at some more details of what unit testing entails, right? So when should we do unit testing? Unit testing should be done actually during the coding of the module, right? And not in the testing phase, right? It's not that we develop the module and then we start testing, right? As we code the module or as we develop a module, we should be doing the unit testing of that as well. And who should be doing this? So the person who writes the code for the module, ideally that person is the one who should be doing the unit testing as well. And what is involved when one does unit testing? So as we saw in the previous video, we need to design test cases, right? So unit test cases have to be designed. And not only that, there is something known as a testing environment for the unit under test, right? So this environment also has to be designed. So what is this testing environment? So let's say we want to test a module, right? So this is the module to be tested. But remember that this module itself might be calling other functions, let's say function 1, 2, and 3. And as of now, right now, these functions are not available to me as a developer of this module, right? It might be under development or it might be in the process of development. And this is written maybe by someone else and not me. So right now, I don't have access to function 1, 2, and 3, for example. And not only that, there are some non-local data or global data which this module has to access. Right? So when I develop a testing environment, I somehow need access to the non-local data as well as these different functions. So in the testing environment, there are two important concepts which we need to consider. And one is known as a stub and the other is known as a driver. So what is a stub? So a stub is nothing but a dummy procedure, right? That has the same signature or the same input-output parameters as the function called by the unit under which we want to test, but it has a very simplified behavior. It's highly simplified. So in the previous screen, we saw functions f1, f2, f3, right? And we know the signatures of these functions, how many parameters, what is the return type, and we create dummy procedures f1, f2, f3, right? And a simplified behavior of each of these functions. And these functions are known as stubs. And the driver module that contains the non-local data structures which will be accessed by the module under test. So we'll be looking at these concepts in detail in this video. Now in Python, there are several unit testing tools, and the most popular ones are unit test and Pytest. So unit test is a built-in standard library for testing Python code. And Pytest is another popular testing tool which is used, and it helps to minimize boilerplate code. So in this video, we will be looking at Pytest. So let's look at a simple example of how we can use Pytest. So in this code is the seller portal code, right, which simulates some parts of the seller portal. So we have a product class, right, wherein you can add a product and view product details. Then you have an inventory which has a map of products and number of items in that product. So it takes a product ID, and for each product ID it has number of items, right? And you can add items to the inventory where the number of items are updated, or you can delete items from the inventory, right? And here we are doing basic checks like, let's say if the number of items in the inventory is less than the number of items to be deleted, it will raise an exception, or it will reduce that many number of items from the inventory, right? And let's say this inventory class is being implemented by some other developer, so they are still in the process of writing the function. So get total items, what it ideally should do is calculate the total number of products in the inventory, right? And it's not implemented yet. And my seller portal is importing the product and the seller inventory classes and creating objects, right? So P1 is a product object, and you're adding objects, and s1 underscore inventory is an inventory object, right? So with this context, now let's see how we can use a testing framework like Pytest. So to install Pytest, what you have to do is just type pip install Pytest, and in my case it's already there. So what I can do is just simply run Pytest, or call the module Pytest, right? And here you can see that the message which comes is no tests ran, right? So for Pytest to run, or what Pytest does is it looks for tests, right, in the given folder. So what I can do is I can create, let's say, a file, right, a Python file called test underscore seller portal.py, right? And it's necessary that the file name should have test underscore at the start, right? And let's say I create a simple function, right? So let's take an example of, let's say, a function which just returns the double of a number, right? And let's say I want to test this. So here again, for each test case, right, I add, or I prefix it with test underscore. So this tells Pytest that this is actually a test case, whereas this is a normal function, right? And now how I actually test is to use the assert keyword. So I can say, let's say, assert double of 10 should be equal to 20, right? So now this test underscore seller portal.py contains my test suite, which contains the set of test cases, right? And right now I just have one, right? And each test case should be prefixed with this test underscore term, right? So now in this, now when I run Pytest, right, it says that one test is passed, right, which is this. Now, for example, if I remove the test underscore, right, and if I save it and if I try running it, it says that no tests ran, right? Similarly, if I rename this to some other value, let's say like ABC, right, run Pytest, again, Pytest says that no tests were run. So it's important that you always add the prefix test underscore to your test suite as well as your test cases, right? Each method where you're checking for a particular test case. All right. So now let's try to see how we can test individual functionalities of the product and the inventory classes, right? So what we will do is, first of all, I will import from product. Let me import the product class, and from inventory, let me import the seller inventory. right? And let's say I'm testing, maybe I want to check if this add items to inventory method is working correctly, right? So what I will do is I will create a test case for add new item to inventory. So it's a standard practice to specify, what the test case does in the method itself, right? And that's a good practice, right? So what I'll have to do is first I would have to create a inventory object, right? So let's say I call inventory equal to, I think it's seller inventory, and let's say S1 is the seller, right? And then I have this function called add items to inventory, which takes the product ID and number of items. So I have inventory dot add items to inventory, which takes, let's say, product P1 and adds 10 units of P1 to the inventory, right? And what it actually does is it updates the seller inventory map, right? So a seller inventory map is nothing but a dictionary which takes the product ID as a key and the number of items as the value. So to check if this function is working correctly, I would just have to, let's say, assert. So I have my inventory. So inventory has the seller inventory map. And if my key P1, right, the corresponding value, if it is 10, right, that means, this function is working correctly. So if I run Pytest now, so I see that one test is passed. Now another functionality which I want to test might be, let's say I have added something previously and I'm adding things again, right? So what I want to test if something which has been added previously, right, does it update the inventory, right? So again, let's say I create an inventory object and then again, let's say I add 10 more entries, right? So now I can assert whether my inventories seller inventory map for P1, it should ideally have 20 items, right? And I can test this. Here it's saying 2 test cases have passed, right? So here, for example, instead of, I would have, forgotten the plus symbol, for example, right? And now if I try running the test, so this means that each time I add something, it does not update it, but it replaces with the current number of items. So now if I run the test case, yes, so here you see that it gives an assertion error right? It asserts that 10, so what this returns is actually 10, right? And that is not equal to 20, right? So the test add previously added item to inventory is failing, right? So I will replace, or I'll correct the error, and now if I run it, all my test cases have passed. Now similarly, I can add other test cases, right? So now there is another method known as delete items, right? So let's say I want to check whether this method is working correctly. So let's say I want to test if, now let's say when I'm deleting items, I want to check if the number of items I'm deleting is less than the total items, right? Less than the total items from inventory, right? So again, let's say if let's say I add 10 items to my inventory, and let's say I'm now deleting from P1, let's say I'm deleting 5, right? Now I want to check if my inventory, right, for P1, it should ideally be 5, right? So now when I run my test cases, yes, so the delete items less than is also working correctly. So if you have noticed in this code, there we have, right now we have 3 test cases, but you can see that, there are some initializations which are happening multiple times, right? So in each test method, we are initializing inventory, right? There is a better way to do this initialization, and that is by using what is known as fixtures, right? So in Python, in Pytest, we can use what is known as a fixture by writing or by creating methods which initialize certain things for us, right? So let's say I can create a method called inventory which does this thing for me, right? It initializes an inventory object, right? And I can return this inventory, right? And now for each of my test cases, right, I can call the inventory method, right, which is a fixture, and that makes this inventory available for the test, right? So I need not initialize it now, right? And so I can do the same thing for the other test cases as well, right? I pass, or I call the inventory function, and now the inventory method is available, the inventory object is available in all the test cases. So now if I run, right, so all the 3 test cases are passed. So using fixtures, we can initialize certain things which we want to do, or create some things which are needed in all the test cases. So we have in the delete items, we have deleted some items which are less than the total items from the inventory, right? Another thing which we can do is the other way around, right? Suppose if I delete items which are more than the total items in the inventory, right? So let's look at the code and let's see what's happening when the items which I want to delete are more than the total items, right? So if the number of items which I want to delete are more than the current number of items, then this throws an exception, right? And in Pytest, we can also test for whether these exceptions have been raised, right? And how we can do that is by using the raises function, and we want to check if value error has been raised, right? So let me just, let's say, add items to the inventory. Let's say I add 10 items, and let's say I want to now delete I want to delete items from the inventory. Let's say I want to delete 20, right? And in this case, it should, right, throw an exception, or it should give a value error, and we can test that using the raises method. So now if I run this, I see that this also passes, right? However, if this was, let's say, 5, right, and it should not raise a value error because 10 is greater than 5, right? So in this case, this will fail, right? So this tells me that my program is running correctly. Now, if we look at the inventory class, right, we have a function called getTotalItems, right, which I said has not been implemented yet. So let's say I have in my inventory, I have product P1 with 10 items and P2 with 10 items or 20 items, right? So the total number of items should be 10 of P1 plus 20 of P2 should be 30, right? So however, this feature has not been implemented yet, right? And maybe the inventory module is being developed by some other developer, right? And for my module, I'm using the inventory module, right, in my application or in my module. So now this causes a problem, right? Because I want to test whether my module is correctly capturing or correctly using the inventory functions, right? However, it has not been implemented yet, right? So let's see how we can work around this problem. So now let's say if I want to test this functionality, right, which has not been implemented yet, which is get total items. So I want to test the total items in my inventory. Again, I have access to the inventory object, right? And let's say I add 10 items here and I add 20 items of P2, right? And now I want to assert that my inventory, so ideally I would want this get total items, right now the current state is 30, right? Now if I try running this, okay, it should give me an error because this function has not been implemented yet, right? And that's why it's giving none, which is equal to 30, and this is failing, right? So how do we work around this problem where we want to use functionalities from other modules which are being developed by other developers, but we don't have access to it yet, right? And this is where the concept of stub comes in, right? We create a mock method or a dummy method, right, which will mimic the functionality of that function or method, right? So what we'll do is we will create what is known as, so I'm creating a function called mock get total items, right, which takes the inventory, right, and it calculates the total, right? So my inventory map has product ID and let's say the number of items, right? Inventory has something known as a seller inventory map, right, which is a dictionary, and I call its items, and for each item I update the total, right? And this function should return total. Now what I will tell this test is, so my inventory functions get my inventory objects get total items should not call the inventory modules get total items, but instead what you can do is mock the functionality, right? And we use what is known as the mock object, and we say the side effect equal to, and the function which we need to call is actually this one, right? So what we are saying is, instead of calling inventories get total items, we are mocking, or we are creating a stub which simulates the functionality, right? And we have simulated it here, and that's what we are calling here, right? So now when we say get total items and we pass the inventory object, now what we are checking is whether this functionality is being implemented. So now if I try to run this I see that all my tests have passed. So in this way, we can use Pytest, right, to test our programs. So we saw that how we can create different test cases to test each method, and in each method we can use it to test different conditions, right? Let's say we have added something to the inventory, we have deleted something from the inventory, and for delete there were other conditions as well. We looked at how we can also check for exceptions, right? And we also saw how we can create mock functions, right? So let's say we have not, or certain functionalities are not available to us, we can create stubs, or we can mock or mimic that functionality using this feature of Pytest.